Welcome at Ask Professor for this last moment in this MOOC. I'm really happy to see that everybody is very active and also nice questions. Now we are looking in the future, always nice. One of the comments was, what about Hyperloop? Is that really the future for passengers into a Hyperloop? I think maybe in the long run, but starting with freight, because you never know what happens when you are in a vacuum tube. So safety first. So I think that should be the starting point. When I have no idea, because there is no actual plan in Europe to invest in this nice idea. But okay, let's see. The nice question is about sustainability and the future proof of sustainability, and what are the topics we will use to improve for the near future. You could say, okay, recycling of materials and all kind of other things to make it more environmental friendly. That is really a goal, and we will. That's no problem. But I think you can also think more about how to make it more easy to do. Less transport of materials or less input of the process. And so you can do it with less people and more efficient. I think there's a lot to gain when you do it in that way. For example, when you have, ballast and you have to transport that because you need ballast truck. That's always a long run from Norway to Holland, and that's also not so friendly. Can it be in another way? Yes, of course. But then you need to make a new plan, a new design, I would say, of your rail construction. And it's really a challenge. You cannot make it that easy to change. What you also can think about, how can we make it more easy to get new techniques using recycled plastic, or how can we do it in an energy way to make it more sustainable? And that's also a second part of the question. How can we use battery, for example? Is that the future, or would it be hydrogen, or would it be biodegradable gasolines or whatever? Everything is more or less possible. We have this already. We have hydrogen. We have locomotives running in a pilot. But the question is, what will be the mass? What will be the mainstream in that area? And that is, in my belief, not the battery. Because when you look at the cycle of to make and how to make this materials out of the Mother Earth, that's not so friendly. And battery only has a lifetime of, say, 7, maybe 10 years. And then you have to renew it. So that's not the way how you have to look at this. So I think that we need the batteries to make hydrogen in the long run. And hydrogen, we can get this generated by the sun. We have a lot of deserts. Why not using hydrogen for the future? But that's my opinion. Maybe you can convince me in a chat or in uploading your ideas in this course. So maybe you have better ideas than me. Let's see. Next question was about the Hilversum case. It was really a problem with the safety, and we had problems in the switch mechanism. And you could say, okay, what's the problem? Is the switch design a problem? Is the switch blade a problem? Is the profile a problem? Like you asked me in the question. But to be honest, it was only a material problem of that small part inside this machine in the pointer. So, yeah, what can you change? I think you can change only the materials quality or the requirements to get a longer lifetime. So fatigue is the problem in this case. So you could say, what would be a better requirement to avoid this fatigue problem? Or you have to renew this part earlier and not waiting till it will fail. So that's a choice you can make. And that's, I think, exactly the engineering task to do. That it was not correct, that's for sure. It was also not giving the guarantee to reach the right life cycle. But that's life, and that's we have to learn from that. And that's exactly what happened. It was a pity that just a small ring gives this problem, this derailment. Thank goodness there were no casualties, so that's the good news on this learning case. The final question of today was about what can you say about light trains and heavy trains and about the damage appearance, cracking or not, or craquelé or something else on the surface of the running band of the rail bar. But the real question is, of course, what is worse? That's one definition. But on the other hand, what is the main reason why you get this cracking? And that's because of the load combination with the contact force, so the radius of your wheel. A bigger wheel has a bigger contact patch, and that means that you have a lower stress level. And lower stress means less chance of cracking, so you have a longer lifetime. So that's the basics. And also the maintenance level, where you have that perfect, nice and in shape, and you keep it in that dimensions, a nice running band and a nice profile on your wheel, it will also a longer lifetime. And also when you grind it, it's also, so everything is connected. The answer is you have a system, you have to be aware what are the ingredients of your system, which are the dominant ones, and which one will control, gives you control on this cracking maintenance level or indications that you have to do something because the connection wheel rail is not correct anymore. That's the real mechanism, and that's a system. It's not easy to give one answer, and that's not maybe satisfying your question, but it is information you have to be aware of, that the system is taking the lead to give the right answer, and there are multiple parameters, so you can choose.
Many thanks for the enthusiastic reactions, and also the amount of people who are really enjoying the MOOC from our group worldwide. So please go on, I would say. You can enroll yourself for the professional education, what you see here also back here in the teaching lab with all the students here in Holland. Please enroll yourself for the following up professional education. You will learn a lot about the design, the engineering, but also the full system of operations, and also the life cycle elements of the railroad and railway engineering parts. I think it's really interesting. You don't have to have your own high-level degree to follow this, so don't be scared of this. And you have to pay for it, so you learn something. That's the other thing. But I think full year of education, you can learn a lot, and you get a lot deep dive how the real system approach working in the railway engineering. So be my guest, and hopefully see you soon, and see you back in the first quarter of next year. Thank you. Bye.